Gold vein localization in inclined magmatic dikes, A to D thermal model validated with El Callao mine data. This study explores how gold veins form in the El Callao mines of Venezuela, where the rock walls are tilted at a 15-degree angle instead of being perfectly vertical. When hot molten rock, a dike, pushes into cooler rock, it creates temperature changes over time, which can influence where gold deposits form. Earlier theories assumed vertical walls, but this new approach accounts for the real-world tilt, making predictions more accurate. By tracking how heat spreads through the inclined rock and identifying where certain temperatures persist, isotherms, the study pinpoints likely gold vein locations. The results match well with actual mine observations, showing that this more complex method better reflects real geological conditions. This improved understanding helps guide gold exploration in similar tilted rock formations. Introduction. Gold deposits often form near hot magma intrusions, where temperature changes influence where veins develop. Earlier studies simplified this process by assuming the magma rock boundary was vertical. However, in Venezuela's El Callao gold mine, the wall is tilted at 15 degrees. This paper improves on past models by accounting for this real-world tilt, leading to more accurate predictions of gold vein locations. By studying how heat spreads from the magma into the surrounding rock, we track key temperature zones, 400 degrees Celsius and 500 degrees Celsius, which help pinpoint where gold is likely to accumulate. Unlike older 1-D models, our 2-D approach better reflects natural conditions, considering heat flow perpendicular to the inclined wall. This method aligns well with actual mine observations, offering a more precise way to explore gold deposits in similar geological settings. The findings build on past work but provide a clearer picture of how tilted magma rock interactions shape gold formation. Conclusion. This study improves how we predict gold vein locations by analyzing heat spread from tilted magma intrusions in rocks. Unlike past models that assumed vertical walls, our approach works for any angle, matching real-world conditions like those in Venezuela's El Callao mine. By tracking key temperature zones, 400–500 degrees C, we identify where gold likely forms, not just along single isotherms but where they cluster. While more mathematically complex than earlier methods, our 2-D model aligns better with actual mine data. The results agree with previous vertical wall models but now apply to natural, non-vertical settings, aiding more accurate gold exploration. This important article is authored by the following scientists. Thank you for watching this video. Please subscribe to our channel BP International to watch more videos in the fields of science, technology and medicine.